Okay, so I'll not repeat what I just said earlier, but basically, I'm just saying that the techniques that we have seen through the presentations, and I strongly encourage you to chat with your colleagues, your classmates who have worked on other technologies that you're interested in, especially the pros and cons. In the first attempt, you may not completely be clear about the pros and cons of everything, but as you get more and more uh, exposed to these topics, I'm sure you'll figure out which is less pricey, or which suits the type of workflow or process that you want to follow, and so on. Okay, so let me actually, so what I'll do now is in the next 25 minutes, cover a couple of topics. So let me start with sharing my screen. Um, yeah, so, okay, let me actually come back here. So I want to quickly cover two specific topics in a little bit of, um, in which are of course abridged, but I hope you can check them out later. First is a continuation of what we saw last time. So this is actually, I wanted to share a link with you guys. So last time, in the second half of last session, we were looking at online experimentation, and we tried out. We saw a package called planout, which helped us in deploying to do A/B testing, which is split testing or randomized control trial. All these mean the same thing. And there are two phases to doing A/B testing. One is you set up an infrastructure where your app, exactly the Flask app or whatever apps that you've been building, those apps, let's say we are using Flask app, for example. The app should just figure out, hey, when the request comes, should I show version A of a prediction or version B of prediction? For example, let's say A corresponds to model 1, B corresponds to model 2. The app has just to figure out, hey, which one to show. And of course, the app itself can flip a coin and show one or the other, but that's kind of hard because if the person refreshes the browser, you need to take care of sessions and so on. So those things are captured into packages. One of the commercial packages is by a vendor called Optimizely. So they have this repository called Python Sdk Demo App. Um, and it's very similar to the app that we saw last time. Okay, so last time we saw a Flask app which had two PyTorch models, and there was a very simple, I guess, web page which was showing, hey, your user number something, I'm going to show you model 1. And if I refresh the page, I would still be the same user. I'll still be showing the model 1. And only if somebody else logs in, or if I reset the page somehow, then I'll be some other user number, and potentially I'll be chosen model 2, and that's randomly chosen. Okay, and we were using planout as the open source um, package to do that, to do the splitting, okay, of any incoming request. Let's show this person model A or model B. This person, not the first request by the browser. Okay, so if you request again, it's the same person, and so you'll see the same model. Okay. So that was what we saw last time. So that was part one. So you need to have this extra package to be, so that app can show you one or the other. And then hopefully the app also logs data. Okay, and for example, uh, you know we haven't seen logging much in this whole course, but for example, the way George was logging his model coefficients, right? So you should log every time you get a request. Hey, what is the request? What did I show? For example, you can log that. And then part two of A/B testing would be, hey, now I have log data where I have now a bunch of people who saw version 1, bunch of people who saw version 2. I have some statistics like, maybe people who saw version 1 of my recommendations, they tended to spend a lot more time on my app, let's say the Netflix app. And maybe for version B, people spent lesser time. So you can do a two sample test, okay, two sample hypothesis test. One classical test is called two sample t-test. Okay, it just looks at the means and the difference between the means appropriately normalized. It looks like it looks like t distributed, so you can compare it with a what is something called a t statistic, and then accept or reject the null, which is like how there's no difference between A and B versus maybe A is different from B, the two options. So we haven't, it's just scratching the surface of hypothesis testing, which we don't want to get into because that's step two. There's so many choices you can make, but step two, in summary, just deals with hypothesis testing once you have these two sets of samples, A and B. And you can also have more options, A, B versus C versus D and all that. And step one, as I said, is about an extra capability so that you can actually in real time when queries come, you bucket them into, hey, this user should see no recommendations from model one, or this user should see recommendations from model two. So that's what we did with planout, and this link is just showing the same thing, how to do it with this vendor's I guess they generally call it SDK. Just think of it as a module, how to do that with Optimizely. Okay, and it essentially does that, and so you can see how to do that. And the nice thing is, because it's related to the Optimizely account, you can actually go back to the Optimizely's web page and see how your app performed. Okay, the app in this case is a simple demo app, but any deployment that you do, you generally want to test out. Okay, and in particular, well, MLOps, it's really important. It comes after deployment, right? Once you have deployed, uh, you don't get to deploy and delete the previous model. You only get to say, hey, we are reasonably confident offline that this new model is better, or in some sense, and then convince the management that, hey, send us some traffic or some bunch of queries that are coming to the existing model, and then do an A/B test, and then you completely convince the management that, hey, the new model that the ML team has developed is actually worthwhile deploying, right? So this is how you do it, and so it's important to get the basics of this, at least to get exposed to the basics of A/B testing. Okay. So yeah, I'll not spend more time on this. Yeah, any questions about Optimizely or what we just discussed? I was just trying to refresh what we did last time towards the end, which is online experimentation demo with Flask. Okay, so let's move forward. The next point that I wanted to quickly discuss is which skipped over a couple of chapters. Okay, so let me actually show you the syllabus. So in the syllabus, we saw web servers, and now everybody is reasonably comfortable with web servers, EC2 machines, and not just EC2 machines. Now that you're very comfortable with EC2 machines, you can get machines from anywhere, from Microsoft's Azure thing, or from GCP, or from other vendors like Linode, or or DigitalOcean, or other things, Vultr, or any of these other vendors. Okay. um, and then we saw serverless infrastructure. Okay. And we saw some projects today, and then we saw Docker, and some very simple ways of using it. um, and then we skipped over a chapter which was talking about Kubernetes as a way to orchestrate a container, orchestrate container deployments. So in the Docker chapter, we actually, sorry, yeah, in the Docker chapter, we saw how to use ECR, this is Elastic Container Registry, as well as an extra managed service called ECS, okay, Elastic Container Service, as a way to manage deploying a container. Okay, so Kubernetes is a very, I guess, complex piece of technology, which is open source, unlike ECS, which is proprietary. It's a technology that I think, I guess, it gets more closer to software engineering, and so it's not specific to MLOps, but it's a technology which helps you deal with lots of containers, lots of machines, orders of hundreds or even thousands of underlying machines, or hundreds of containers doing various different things. You can have a container for a database, you can have a container for all the things that you saw, like data prep, ETL jobs, deployments, even having dashboards for internal folks to see, and things like that, right? Several things can be done using this, so it's an orchestrating tool, and so we skipped that. um, and then we talked a little bit about pipelines, and in pipelines, we just talked about what types of pipelines they were there. And at this point, we couldn't really see a cron in action. We ran out of time, I think, in that session. And we also didn't see Apache Airflow in action, but these two are something that we skipped. Okay. Now, coming back to the full chapters that we skipped, that is chapter 6 and chapter 7. Chapter 6 was supposed to talk about Spark ecosystem. And Spark is a technology, I guess, the informal phrase you want to use is the big data space, right? So I think we, in fact, have a course called Big Data that I assume some of you have taken or will take. Uh, so, uh, so chapter 6 was supposed to introduce Spark to you folks. It's not about deployment. This part is about uh, training and data prep. And how do you do training and data prep when you're not limited to single machines? Okay. So far, whether you pick an EC2 machine like like someone with did, like with the ml.m4.xlarge and so on. So you're not, how do you deal with data when you can't put it in a single machine, right? So your data, let's say it lies on S3 or somewhere like Google Cloud Storage. Now you want to read the data. Maybe it's maybe it's in BigQuery. You want to read the data, but you can't read the data because the largest machine that you can get maybe has 256 gigabytes of RAM and maybe like several terabytes of hard disk. Even that may not be enough. Okay, and that's increasingly becoming true with a lot of. It doesn't, it's not even this. It's not just for Google's and Facebook's of the world that's the situation. Any company, let's say a game company which has game-related apps on, let's say, the App Store, they collect a lot of data about how the games are performing, what's the latency, how the users are activating or using different aspects of your game, and so on. So generally these event data, or I guess product data, there's a lot of data like that. Okay, not just, and there's of course on web, there's a lot of web-based analytics that folks do. uh, these are just two example use cases let's say in the tech space, but I'm sure there's, in financial data also, depending on the type of data, it may not fit in a single machine. Okay, in that case, you want to use Spark, which we have skipped. So I will just briefly show you um, an example vendor where you can try to explore this after the class or after this course, and then something related to that, which we will definitely skip. We don't have time at all. Is something called streaming. Okay, in streaming, you don't really consider data to be at rest. Okay, which means that there is, think of again a game app, right? So somebody created a game, and you have let's say 100,000 users who have downloaded your app and are playing the game. And so when they play the game, maybe there are some network requests, so they have to, there's some request going back to one of the APIs. Maybe it's a prediction API that you have built. Okay, so there'll be several 100,000 requests potentially, right? If everybody is on at the same time. And these requests can you don't have to write the request down to write these requests, as in like what was the request or what was the state of the game in each of these users app. You don't have to write it down onto like an S3 or somewhere and then make a prediction. Okay, you can actually on the fly, when the request comes, you make a prediction, very similar to how we have deployed a model. But uh, the idea here is that you don't ever think of data being residing on disk ever. Okay, so you get data in a streaming fashion, which means that you don't think about it as lying on somewhere, maybe on a disk or a database. And so the whole model, the data processing model, is very different from what we have seen in the rest of the chapters. Okay, rest of the sessions, in fact. So we have not seen streaming at all, but um, it's a very important idea. And one of the technologies that we were going to see but we haven't seen is called Apache Kafka. But there are managed services that I can probably quickly show you, perhaps, which do that. For example, yeah. So if you go to GCP, and on the left side, you'll see a tons of managed services, right? App Engine is something that was one of the projects. Kubernetes is what we just also discussed, that this is one of the ways to orchestrate or manage containers. We haven't seen it. Cloud Functions we have seen, and so on. So if you scroll all the way down, to networking. And then there's a whole subset of managed services related to big data. Okay, so you can see here there's something called big data here. And here you can see there's ideas such as pub/sub. So these are all ideas, not all of them are related to streaming, but pub/sub, for example, is something related to streaming way of doing things. Okay, streaming way of doing predictions, passing information from one I guess service to another service, and so on. Okay. And just as a quick tangent, you can also see a lot of AI managed services that are available on Google Cloud. Just like I think last time I showed you on AWS, there's a machine learning subtopic. If you look at all the services, and there's like a SageMaker and many other things on that list. Similarly, Google has AI, subtopic, as well as big data subtopic, and they have things related to natural processing, things related to data labeling, all these things. So worth checking out. So let me come back to here. So those are two things that we skipped. Okay, streaming model and Spark in detail, and then we did cover online experimentation. So let me what I wanted to do was quickly show you an example of a okay, let me an example of something that you're very familiar with, which is Jupyter Notebooks. Okay, we have been using Jupyter Notebooks quite a bit. So there is a vendor called Databricks, and there's something called Community Edition of Databricks. It's a web-based interface. Again, the same idea. It's like so. We're not talking about deployment. We're talking about, let's say, training. Okay, this vendor is able to will give you at least in the Community Edition a small instance for you to play around with Spark. Okay, Spark is something that, as I said, you will see if you take the big data course. If some of you will take the big data course, if not, just think of it as a way to deal with really large data. Okay, data that is not on a single machine; it could be on multiple machines. You'll be able to work with it. So let me sign in. Okay. So you'll see an interface. So I just created an account already, but I encourage folks to have a look at this when you have time. So let me give you the link here in the chat. You don't have to create a login now, but so what I wanted to show you in the next, I guess, couple of minutes was that, hey, the interface is exactly the same as what we've seen throughout the course. So let's just click on Explore the Quick Start tutorial. And you'll see that this is actually very similar to a what is it called, a Jupyter notebook. Okay, so these are all Jupyter notebooks. In particular, this notebook is actually in SQL. So folks who know a SQL, then they can actually work with it. Okay, but you can actually do Python. So if you click on Workspace, I actually have lots of notebooks here. Let me create a notebook, and it says, hey, what's the notebook? It's Python, and let me just create the notebook. So so this is a notebook. So I can do print hello world, but it will not print because I did not even create an underlying cluster. Okay, so the way this vendor works is you have these notebooks, but you cannot run them unless there's an underlying machine which can run this notebook, right? And that machine you can actually create here. I will not show you, but in the free edition, you can certainly create a small cluster where you can try out Python itself. But the more important point is that it's not just, you don't want to just try out Python here. I mean, that you can already do in Jupyter Notebook instances that you have on EC2 and all that. What you can try out is Spark. Okay, so Spark that, like, for example, you can do queries. Actually, the quick start had some ideas, right? So let me just go back here. So you can see, for example, you can run some commands like spark.read a data from somewhere, and then you can see the table is exactly like data frame that you might have seen earlier. But the nice thing is this interface, or Spark in general, with this interface, for example, and in particular a package called PySpark, it makes you agnostic to the fact that the underlying data. So although we are seeing this table here, for example, from a table called diamonds, the underlying data may be in multiple machines. Okay, in your cluster. If your cluster has 10 machines, underlying machines, the data could be spread out. In fact, it will typically be spread out across these 10 machines. But from the notebook, when you have, let's say, an equivalent thing called a data frame, even in Spark, it's going to be exactly as if you're working on a single machine. That's what all these cluster-based ideas do. They are trying to obfuscate, or at least not obfuscate, but make you agnostic to the fact that underlying thing is actually distributed, and computation, big data computations are happening in a distributed way, like whatever ATL stuff that you want to do. Okay, some data pre-processing stuff you want to do. But we don't have time for that. So I just wanted to quickly show you that this is something uh, that is there in chapter 6. I will update the chapter if the material is not completely fleshed out, but have a look at it later. Um, with that, let me actually really wrap up the course with a few comments on things that we did not see. Okay, so things that we saw are already in the syllabus page. So I strongly encourage to folks to have a look at the syllabus page to get a feel for what all we saw. But there's another notebook that I just updated earlier today, which shows you some of the names of technologies that you can try out, right? Um, Names of technologies that we did not cover, but some of them should be useful for you in your toolkit. Okay. So for example, in terms of web frameworks, we use Flask, which is very, it's relatively straightforward to use once you get familiar with it. But there are more, I guess, there are more feature-rich web frameworks like Django, which is quite popular in the Python realm, and there are many others in depending on your language of choice um, that we've not seen. Okay. Uh, we have, Django is not there in the notes, but we have references to these things in the, for example, the exercises. For containers, as I said, Kubernetes is something that we do not see, but it's present in the notes. There's also reference to something called VirtualBox, which is a way to get a virtual machine on your laptop, whether you're a Mac user, a Windows user, or a Linux user. It's free software currently for personal use, so you can. That's something that's there in the notes, but we have not done it. And as I said, for example, scheduling, we did not do cron and airflow in the sessions, but it's the notes are there for you to figure out how to schedule your training jobs or deployment jobs or data prep jobs. Okay, for example, you're scraping a website, you want to scrape it every day, then you can run a cron job and things like that. Okay. uh, what I wanted to say was that there are few important technologies that we have not seen, and also some ideas that we have not touched, but they are very useful to kind of make your MLOps skill set, I guess, have more depth. Okay, or more depth and breadth. So first thing is, so this is not in any particular order, but for example, today we saw Son and his teammate use um, Shiny as a package. So instead of Jupyter Notebooks, you can actually run RStudio as a server, on a server like the EC2 machine that you have, and actually get the RStudio interface in the browser, in your browser. Okay, so you can try that if you want, if you are interested in R-based remote machine, so that you don't have to install RStudio on your local machine, and you can from any laptop or anywhere, you can just log into that remote machine and continue your work. We haven't seen databases at all. There's a database course that some of you will take, or all of you will take, especially in one of the programs. So there's SQLite, as well as many other feature-rich databases technologies that you can use. Virtual machines, we did not end up using or explicitly seeing virtual machines, but most of the machines that you rented out, like EC2 machine, it's a virtual machine actually. At the end of the day, it's not a. I guess if it's not a virtual machine, the vendors will explicitly say it's a bare metal instance. Okay, bare metal instance means it's not a virtual machine. It's really the full machine. Okay. So there are many softwares related to that. VirtualBox is one of them, which is there in one of the notes, because it's needed for Kubernetes. But if not, try out VirtualBox. You can try out different operating systems, Linux, for example, right? In Python, we really didn't do, we only scratched the surface because we didn't really care about expertise in Python. But now that you are a little bit familiar with the basics of Python, there are several things that you could check out. For example, in Flask, you've seen that @app.route, right? So there's some @app.route before your function call. Okay, So that at the rate function, at the rate, that extra statement on top of your function in the Flask script, that's called a function decorator. Okay, so that's a little bit of an advanced feature. I will not discuss it now. We definitely don't have time, but there are ideas like that you should get exposed to, especially testing your code, linting your code, which is about variables are nicely written, code is formatted, and things like that, and many other things. Okay. Managed services, and today we saw SageMaker. There are many other managed services as we just discussed. Most important tool I would say that you would want to prioritize is Git version control. It's just a snapshotting idea from like same thing that you would do with Google Docs or Microsoft Word, where you have revisions, the same idea but with code, and it's quite feature rich. So try that one out as well. Uh, we haven't tried out integrated development environments, and these are useful for even a data scientist or a business analyst, where if you partially write a function, it'll complete it, auto-complete it, it'll give suggestions, for example. So IDEs do that in addition to many other things. So here are some names that you can try out. Linux utilities, we have been using them quite a bit. We didn't explicitly call them out. We have been using Bash, which is the terminal, basically, SSH, Vim, curl, we said, is a way to make requests, and so on, AWS CLI, gcloud. So getting more exposed or getting stronger in these skills will really help you. And as I said, there are many other things that we can cover, but we just don't have time. Anyway, so I think we are really out of time, but any questions? Okay, so if there are questions, I'll certainly stay back and ask me questions. If not, thank you for joining me in this course, and I hope everybody had some experience trying out different technologies, whether it be not on deployment, but maybe data prep, data training part of it, whatnot. So thank you everyone again, and I hope to see you in some other course or maybe offline. Yeah.
Thank you, Professor. It was a lot of learning. I know I felt 8 weeks is too short for this. And yeah, today's presentations were great. We learned a lot just by listening to others and seeing. Yeah, I think it was really nice.
Yeah. Thank you.